Hello, welcome once again to the channel. Now today, we're also looking at one topic that normally also appears in the BEC. We are going to look at it swiftly. We are going to give you the points and how you are going to do this easily. And the tricks, everything you need to understand under what? Under mappings. So I'll be hitting on the points. Since it's a final year class, I'll be hitting on the points that you need to know. Once you know them, you can solve any mapping question. Let's understand. So yours is to just open your mind and listen. Once you listen, you apply them, they work, and you're fine. Good. Now, in mappings, there are certain things we need to know. And one thing I always tell students that when it comes to math is very, very easy because it deals with principles. What are the principles here? Mapping is coming from something we call as well relation, or something known as well relation. When we say relation, it's basically a link or a connection between two things. If I have a set X, let's go deep now. I'll just be quick here. If I have a set X and a set Y, a set X and Y, then I have members of X and members of Y. How are the members of X related to the members of Y? That how is the relation. Are they friends? Are they enemies? What are they? Are they square off? So, for instance, if I have 2, I have 4, and I have 3, and here I have 4, I have 16, and I have 9. These two maps onto this 2 is connected, this 2 is connected to that. See what I'm going to do with this. See, I'm going to play with this and we'll finish this thing soon. Listen to this. I said this is a Form 3 class, so we need to hit on a point and we are there with mapping. So you can do everything after this video. Good. So I'm saying that once we have this guy is mapping onto this. So there is a relation connecting them. There's something that is linking this one to that one. That's what we call relation. That relation is what we refer to as the rule of any mapping. Listen, the rule for the mapping is basically a relation. Before a relation will qualify to be a mapping, then one member of the domain, these X values are, I've mentioned a term, so let me explain that. These X values, the members or the set of X are referred to as well, the domain values. So these values are called the domain. And the Y values are called the what? The codomain. Listen carefully. You understand this? Mappings have their roots in what? Relations. And I'm saying that for relations, what do we have? Relation simply means a connection, association, or a link between two sets. And I have two sets here, a set X and a set what? Y. I said the members of X are referred to as what? The domain. That of Y are referred to as what? The codomain. Okay, now this X is connected to 4. This is connected. What is connecting them? They all must have the same connection. And the connection is that it's a square of. When I square 2, I get what? 4. When I square 4, I get 16. When I square 3, I get 9. So the relation here is that it's a square of. A square of. So 2 is a square of. 4 is a square of. 3 is a square of. This is what is happening here. So this is the what? This is our mapping. That means in mappings, we need to have a domain. We need to have a link or a connection. What we call the rule of any mapping, then we have the what? Codomain values. Listen to what I'm saying. This is all you need to know. In any mappings, I said that we have what? We have domain. There's a link between the domain and the codomain, and that link is what we call what? The rule. So the question says, go and find the rule of the mapping. That means they want the connection between the domain and the codomain. And the question must give you the domain values and the codomain. If not, you can't find the rule. So there are 3 things here. There are domain, there's a codomain, and we have what? Rule. In any question, the question must give us 2. Either the question gives us the domain and the codomain. So we find them the what? The rule. And that is an aligning principle of any math topic. If there's a formula, if there's a relation of getting something, the question must give us 2 of the parameters. So I call this one the first, second, and third. So there are 3 parameters here. You understand what I'm saying as we get to the end and we take the questions to solve. So now we've understood that. Let's come to this. The members I'm calling the codomain, when they map onto anyone here, any guy who is mapped onto by a member of the domain is an image. Bravo. Anyone who is mapped onto, so since 4 is mapped on by 2, and 16 is mapped on by what? By 4, and 9 is mapped on by 3. then these guys are referred to as what? The images. If you collect all the images, so these guys are the images. If you collect all the images, you form what? You form a range. So a range is basically a collection of all the what? Images. Now, for this to be clear, let me give another example. Say I have 1, 2, 3, and 4. These are my codomain values, and these are my domain what? Values. So for my domain values, say I have let me put 9 here. Let me put 4 here. Let me put 16 here. Okay. Okay. Let me put 1 here. Let me just do this. Let me do this. Now, 1 maps onto what? 1. 2 maps onto 4, and 3 maps onto what? Onto 9. Once again, I'm using the same link, the same rule. What's the rule? The rule is that we are what? We are square of this. You see, this 1 is mapped onto 1. 2 is mapped onto what? This, and 3 is mapped onto 9. Since one member here is mapping onto one member, such a relation qualifies to be a mapping. Okay, now I said all those that are mapped onto in the codomain are images. All those that are mapped onto in the what? In the codomain are images. You know what I'm saying here? Good. So let me add another one to this. Let me add some 17 to this. Yeah. Let me add 17. I want to do something. I just want to do something. All those that are mapped onto, in the codomain are referred to as images. A collection of the images gives you the range. So these are the codomain values. 1, 9, 4, 17. They are the codomain values. No problem. But we want those that are mapped on by a value from the domain. Which ones are that? This, that, and that. So we collect them and they become what? The images. A collection of the images will give us the range. So a range is basically a collection. For this, our range will be what? Will be 1, 4, and what? 9. 17 is not part. Why? Because no one mapped onto 17. I don't know if you get the point I'm making here. Good. So that is how we find what? We find range. Or we know what the range is. So that being said, let's come back to this guy. I've said that in mappings, we have the domain, we have the codomain, and we have what? We have the rule. For you to qualify as a mapping, then one member of your domain must map onto one and only one member. You map onto 2 members? No. So 1-to-1 relation and many-to-one relations are referred to as what? Mapping. Many-to-many and one-to-many are not mappings. They are relations, but they are not mapping. We have 4 types of what? Relations. We are not going deep into it, but we are just hitting on the points we need. So now let's come back here to this. Now mappings, we also have types of mappings. But these are level. We deal with only one type of mapping, the linear mapping. We have 2 types of mapping. We have one. We have linear mappings. And linear mappings will always give you a line. If you draw the graph of it, you get a line. That's why it's linear in the form of a line. And generally, all linear mappings are of the form y equals ax plus b. All linear mappings. Once it's in a line, we have y equals what? Ax plus b. Then the second one we have are the exponential. We have the exponential what? Mappings. But these, we don't go deep into that here. So I want to just go to this. When you come to a system, there's a need for us. I will do exponential mappings for you. There's a need for us to do it, but at this GSM, we're not going to look deep into this. We are going to look at this. And also, I just want to make sure you can understand your mappings. Then move on. You get the point where I'm going to solve our BEC. That's what we need here right now. We don't need to talk much. Okay, so let's go. Now, I said earlier, and maybe you missed that point. So take this point again. In this, we have 3 parameters. We have domain, we have rule, and we have work. These are the 3 parameters we have here. In any question, if you read the question, they find the rule of the mapping, then the question has given you the domain and the what? Codomain. Without these 2, you can't find it. And this is the principle in math. In any expression or formula you know in math, if the formula has 4 parameters, as in, let me use an example. We take the volume, I want a curved surface area, no, let me take volume of a cylinder. So volume, let me take volume of a cylinder, just to explain something, right? Just to explain something. You know that equals what? Equals pi r squared what? H. Pi r squared H. That means the base area times the what? The height. Okay, so pi r squared H. How many parameters will we have here? We have the volume as one parameter. We have pi We have radius and we have what? Height. Pi is a constant, so the question will always give it to us as 22/7 or 3.142. These are constant values. That means we are left with how many unknown parameters? 1, 2, 3. In any case, listen, in any question, the question must give us two of the parameters for us to find this. So the question must either give us the radius and the height for us to go and find them the volume, or we are giving the radius and the volume for us to go and find the height, or they just must manipulate. But the problem here is that in giving us these parameters, they either give it to us directly or indirectly. When it's given directly, everybody understands. We substitute, we work, and we have. But it's given indirectly. That's why we have challenges with that. I'll also come down and break down this topic for you, so we'll go deep into it. I don't want to waste time with that. So when I come, I'll say it again. So now, we want to learn how to find a rule or how to deal with this linear. I said, any question that asks you to find rule must give you the domain and the what? And the codomain values, right? So let's try an example by finding the rule of a mapping. Finding the rule of a mapping. Very easy. Once my question says find the rule, what do you expect me to give you? We have domain, codomain, and rule. So if I say find the rule of the mapping, then expect me to give you the x values and the what? And the y values. Once I give them to you, should be able to find the what? The rule. If I don't give those values, there's no way you can find the rule. Good. So let's say I have x mapping onto what? Onto y. Onto y. And I have 0 mapping onto, let's say, 2. Then 1 maps onto 4. Then 2 maps onto 6. Then 3 maps onto 8. Let's have this. Now, how are they connected? You see the x values here. I have given you the domain. I've given you the domain. Then I've also given you the codomain. People, what am I left to find to fulfill this thing? I need the rule. So the question will tell you, go and find the rule. The question will never tell you, find the domain values. No. Then the question is not correct, because if you already have the domain to go and find the domain values, then what do I do for you? You have to give me a parameter you don't have. That's how we do math. Hope you understand what I'm saying here. So here I want to find the rule of the what? Of the mapping, because we have the domain and the what? Codomain. First of all, we have to check if the mapping set is linear or not. If the mapping is linear, then we can follow this and move on. Very simple, very simple. Listen, right? Good. Now let's see if this is linear or not. For you to know whether a mapping is linear or not, come to your codomain. Come to your codomain. Codomain needs to come to codomain and check the difference in the codomain. If there is a common difference, I say again, there is a common difference in the codomain value. That means the mapping qualifies to be what? To be a linear what? Mapping. The mapping qualifies to be what? A linear mapping. Let's see how we find the difference. Difference means we are subtracting. Then common means it should be the same answer in our subtraction. That's the meaning of common difference. So I take this first 2 pair and I subtract 2 from. Don't get confused. There are times you put negative. Don't get confused. Understand what I'm saying. That it is the first from the last. The last I told you that your end should be better than your what? Beginning. If I want to know how far you have gone in this life or with whatever you are doing, I'll check where you are now and where you started from, subtracted your start point from your end point, and say, okay, this guy has done well, or that is what is happening here. Math is basically life. So I take this and I subtract from this. So this gives me 4 minus 2, which gives me what? 2. And I subtract 4 from it, gives me 2. 6 from 8 also gives me what? 6 from 8 gives me 2. You can see the difference is common. And this mapping qualifies to be what? A linear map. What are we doing here? We are finding the rule. So the question is, find the rule of the mapping. We should find the rule of the mapping. No problem. Then they gave us the domain and the codomain. So straight away we move into that. So now that we know it's linear, we'll say that, okay, generally, once we know it's linear now, generally, for linear mappings, y equals what? Ax plus b. This is what we know. Now, our job here, me plus you, those of us, our job is to find the value of a and b. X and y will still be in our formula, so we don't care. X and y will still be part of it. So as for these guys, we replace with numbers, and that's what forms the rule. So we are going to learn how to find a, find b, then we are completed with what we've completed with our rule. So let's go. Now, to find a is very simple. A is the difference in the codomain over the difference in the domain. Now that we know it's linear, we say A equals what? The difference in the codomain The difference in the codomain over the difference in the what? In the domain. So this is how we get A. Very simple, man. We get A very simple. Okay, so what is A? A will give me, we found a difference in the codomain as well, 2. So 2 over, what the difference in the domain? 0 from 1 is 1, 1 from 2 is 2, 2 from 3 is 3. So I have what? I have 1. Therefore, A equals what? Equals 2. Now we have A equals 2, then our rule is now making sense by saying that Y equals 2x plus what? B. Why am I saying 2x plus B? Now I have A to be what? 2. So I substitute this 2 into its position. Remember I said that we're looking for only A and what? B. X and Y, we have no problem with that. Good. So now let's see how we can find B. So in any rule, when you find a rule, your job, my job, is to know the value of A and the value of who? B. Okay, so let's go and find B. In order to find B, we choose corresponding X and Y values. We can say that where X is 2, Y should be what? 6. Or where X is 1, you choose corresponding values. So I want to say that where my X equals 1, my Y equals what? 4. And I substitute and solve for B. So whenever I see Y, I place 4. So 4 should be equal to 2 times of 1, because my X is 1, plus what? B. So this gives me what? 4 equals 2 plus B. I need B. This will cross. So 4 minus 2 equals what? B. So therefore, B should be equal to what? 2. Now that I have B to be 2, I'm going to substitute that 2 back into this and I get my rule. Because my rule should have what? A and B replaced with what? Numbers. So Y should be equal to 2x plus 2, right? B is 2, so 2x plus what? Plus 2. Are we there? Are we there? Okay. So now let's test the validity of this rule. Let's see if it's correct. That means I'm going to pick any of the codomain values, in fact, any of the X values, and substitute that value here. If I do my substitution here and I should get an answer that corresponds with what? With a Y. So let's try. If X is 0, let's put 0 here. That means substituting 0, we'll have Y equals 2 into bracket 0. Why not? Because I've chosen X to be what? 0 plus 2. 0 times 2 is 0 plus 2. Therefore, my Y is equal to what? 2. Makes sense. 0 mapped onto what? That means my rule is correct. Let me try the last one, 3. So I'll get Y equals 2 into bracket 3 plus what? 2. When I have this and this will give me what? Will give me 6 plus 2. Y should be what? 8. I go back to check and 3 map onto what? 8. This tells me that the rule is what? Is correct. The rule is correct. So the rule for the mapping is what? Is Y equals 2x plus 1. Everyone is obeying. Like we said earlier, all of them must obey what? The rule. I hope you are okay with this. That's how we find it. Good. So let's take another example. Let's take a second example. There are times you can do what we call method of inspection. Method of inspection, you look at it, look at what is happening, and you can tell what the rule will be. Like in section B, when I ask to solve this, I will solve this. If in section A, I've told you already, if you watch the videos on the section A, mappings, we don't solve them. All we do is I pick the values into them, which rule is working, and you go with that rule. How do you get this? Okay, so let's go. Say we have, once again, our codomain values X. We have 0. We have 3, we have 6, we have 9, 0, 3, 6, 9, then I have maybe 11. Okay, this maps onto Y, then this maps onto 0, maps onto 6. This one give me 12. 12. Let this one give me good. Let's see if I can find the rule for this mapping. Let's see if I can find the rule for this mapping. If I can find the rule for this mapping. Let me change the top one. Okay, let's go with the top. Let's go. I know what. Let's go. So here, first of all, we check whether the linear is mapping or exponential, because we can have linear mappings and have what? Exponential mappings. How do we check if the mapping is linear? We subtract this from that. So when I subtract 6 from 12, it gives me what? 6. Now we should get a common difference. I subtract 12 from 18, gives me 6. 18 from 24 gives me 6, and 24 from also gives me what? 6. So that means the common difference here is what? 6. 6, then I can say that, oh, it's linear. Since it's linear, then generally, All linear mappings are of the form y equals what? Ax plus b. What's our job here? Yes, what's our job? Our job is to find A and also find what? B. So how do we find A? I said A equals what? Equals the difference in the codomain or the difference in the domain. So A equals what? The difference in the codomain. We know that to be 6. So difference in the codomain. The codomain, not the domain. Take note. If a student do the domain, it's not so. It's the codomain, and that's a gradient. We're gradient changing y or changing what? X. It makes sense. That's the link there. Okay, so this is what. Then the domain. The domain. So we have this. So A should be equal to A equals what? A equals 6 over. Let's go and find the difference in the domain. 0 from 3 is 3. 0 from 6 is 3. 3 from 6 is 3. 3 from 9 is 3. And that is also what? 3. So this gives me 3. How we get this? We can cancel. So this goes here 1 and goes there what? 2. So I get A equals what? 2. Now that I have A equals 2, what do? I'm going to fix that into this relation to give me the first part of the rule. So I'll get y equals 2 into bracket x or 2x plus what? B. Now we have to find B. How do we find B? Choose any corresponding values. Yes, what should we choose? What value? Let's choose 6 and 18. So we'll have where we tell the person that where x equals what? 6, then y equals what? 18. So this gives me 18 equals 2 into bracket 6 plus b, right? Okay, so let's go. This will give me 18. 18 equals, that is 12 plus what? B. So b should be equal to 18 minus what? 12. B will be equal to 6. So we have b to be 6. Therefore, our rule, the rule will be equal to what? Y, or the rule is y equals 2x plus what? 6. 2x plus 6. Let's see if it's correct. Let's go and try if it's correct. So let's choose any value. Let's choose 9 and let's choose where x is 9. So for x is 9, we'll get y equals 2 into bracket 9 plus 6. 9 2 is what? 18. 18 plus 6. That gives us 24. Did we get 24? Yes. 9 mapped onto 24. That means these are rule checked out what? You can try a lot. So that's how we find the rule of what? Of the mapping. In this case, once again, I was giving this and that. How do you understand what I'm saying here? Now, there are times the question trying to find the inverse of the rule. Let me talk of inverse before I move on. It says find the inverse of the rule. So, inverse of a mapping. So, we call that mapping inverse or inverse of the mapping. So, inverse of mappings. Let's just put this one here before I forget. The inverse of mappings. Now, for inverse of mappings, it's very easy. Once you have the rule, just take the rule. So for this, I'll take the rule as y equals 2x plus 6. If I'm finding the inverse, then what do? I'll interchange to find the inverse. After getting your rule, I will have to find the inverse of what? Of this mapping. Or the inverse, the inverse for this mapping. You first of all have to go through the process, get the rule. After getting the rule, what do? After getting the rule, then you are going to say that, okay, y should be equal to, you interchange and tell me that x should be equal to 2y plus what? 6. Interchange the values of this and this and make y the subject. So here we do what? We interchange. So the first thing here is to what? Interchange. Interchange the x and the what? And the y. So that's the first thing. After interchanging, then we make y the subject. So here I just want to put this one there for it to make it easy for you. Make y the subject of the relation. Then that becomes your what? Your inverse mapping or the rule for the inverse. So this gives me what? We'll have x minus 6 equals 2 what? 2y. We need y. So this one will cross. So y should be equal to x minus 6 over 2. This is the inverse of the what? Of the mapping. Okay, understand what I'm saying here? So if you're asked to find inverse, make sure you find the rule. So after finding the rule, what do? We interchange the value of x and y, or interchange x and y, then we make y the what? The subject. Very, very well. Easy. Let me take some 2 rules and let's find the inverse. Say we have a rule. We have a rule. Y equals 2x minus 1. Y equals 2x minus 1. We are supposed to what? To find the inverse of this. To find the inverse of this, the first thing says for interchange. So I'll get x equals 2y minus what? 1. This will cross, I'll get x plus 1 equals to y. Y should be equal to x plus 1 over 2. This is how to find the inverse. So once you go to the rule, then you find the inverse there. What did I do? I had to interchange the values of this and that, then make y the subject, and that is my inverse. Okay, that's what I'm saying here. Good. Now getting to the end of the mappings, these are some of the things you need to know. Now, the question would have said, the question can say, find the image. If a question says find the image, that's a y value. That means the question must give you a codomain and a rule. Very simple. Find the image. I'm finding image. That's a y value. What do I need? You, the question, must give me the x value and the rule. Here I can't find rule. So the question says find the image. Let's create one thing here. Find the image. Find the image of 4 under the rule y equals, or they can say x maps onto 2x plus 4. So find the image. If you tell me to find image, then that means you have to give me a domain value and a rule. Then that tells me that this is my domain value. So this is an x value, and this is the rule. All you substitute and get your y. Okay, that's what I'm saying here. Because I've told you that we have domain to deal with. We have domain, we have codomain. Well, let me put a rule here. We have rule and we have codomain. And the codomain values are x values. The domain values are y values. You also learn that the image and the range are all y values. And the rule. So if you tell me find the image, that means you want me to find you a y value. Therefore, I expect you to give me an x value and a rule. And the question obeyed that. What the question do? The question gave us the x value, which is 4, and the rule. So we just find the y value for them. But where's our equation? Yes, let me explain something here for you. Remember in the arrow diagrams of mapping, we say x maps onto y. And when we find the rule, after finding we say y equals this. So if y equals, I can then say that x is mapping onto 2x plus 6. I can say this. Because the same as the y. So that's how sometimes they will do this. When they write this one for you, don't get confused. You can also change it to y equals 2x plus 4. It's correct. You can do it. It's also fine. I hope you get the point I'm making here. You understand what I'm saying? Good. So now let's solve this for them. Let's solve this. So solution. We have our x to be 4. So we have x maps onto 2x plus 4. So that will give me what do we have? We say x is 4. So 4 should map onto which y? That will be 2 times of what? Of 4 plus 4. 2 4 is what? 2 4 is 8, or 4 2 is 8 plus 4. And that gives us what? That gives me 12. That means in the mapping, 4 is mapping onto what? 12. That's what it means. 4 is mapping onto what? 12. So the image, therefore, the image is what? Is 12. Or the image is equal to 12. If I'm writing the arrow diagram, this is what I have. So don't get confused. When the question is given to you, your main thing is that, what do I have? I have domain, which is an x value, and a rule. That means automatically have to find them that. I hope you get the point I'm making here. If the question says that the image of the mapping of the rule is this, the image is that, and the rule, that means you have to go and find x. The image of the mapping, let me set a question on that so that we know how it goes up and down. That scale. The question says that the image of the mapping x is to 3x minus 2 is, let's say, 13. Let us put 13. The question will tell you find x. You finding x, which is the domain value, means that the question should have given you the codomain, which is the y value, and the what? And the x value. And the rule, sorry. And the rule. So they'll give you the rule and the what? And the y value. That's why they want to go and find x. And there are 3 things here: domain, or x, y, and rule. So if you tell me to go and find x, then I need y, and I need what? The rule. So in this case, very easy. I'll say that let this maps onto what? Let this map onto this. Let me use a black. Say that, or I can write y is equal to 3x minus what? Minus 2. So I can write the same thing. I demonstrate that here. So where I see y, I'm putting 13. So 13 should be equal to 3x minus what? 2. I need x. So this one will cross. I'll get 13 plus 2 equals what? 3x. I'll get 15 equals 3x. So x should be equal to 15 over 3. This will go into solve 1, 3, 5, 15. So 5. Therefore, the x value equals what? 5. That means 5 map onto what? 13 in the mapping. 5 map onto 13. So 5 will map onto 13. This is what mapping is about. For our level, this is what we are going to do. So in any case, when you're asked to, but if it's a section A and the rule is given to you, all you do is pick the values and see which rule is working. Don't go and work all that we've done in section A. I've told you. No, we don't waste time. You just look at it and find we are gone. So I hope you understand these mappings. Yeah, this is basically how we treat what? Mappings. So for mappings, you have to know how to find the rule. I've given you the tricks in find the rule. I've introduced you to the inverse. In case this time they give us inverse, look, we get the rule, we interchange, make the subject, then straight away we are gone. I hope you understand what I'm saying. Good. So people, basically this is the end of what? Of our mapping. And we shall meet again. Make sure you go through this and share with all your friends. The price is almost at hand, so they can also get it. Thank you.